If you are measuring squat jump performance and counter movement jump performance in your athletes, today I'm going to show you a way that you can combine the analysis of these two jumps to get more insights into your athletes' physical capacities and the training programs that may be best suited to them. Hi, I'm Clubb, founder and sports science consultant at Global Performance Insights, a company that provides sports science insights to professional teams, governing bodies, sports tech companies, and athletes and practitioners all around the world. In this video, I'm going to be discussing the Eccentric Utilization Ratio, the EUR, its pros, its cons, and how you might use it to help guide your programming decisions with your athletes. The Eccentric Utilization Ratio is the ratio of performance in the counter movement jump compared to a squat jump. You can calculate it using a number of different metrics depending on the technology that you have available to you. Most commonly used in the literature is jump height or peak power. If you're using force plates such as Bowl Performance ForceDecks, you can use peak power from your counter movement jump and your squat jump in your athletes to determine the EUR. This ratio reflects the effectiveness of an individual to use their stretch shortening cycle. In theory, a counter movement jump, because of that ability to use the stretch shortening cycle, should enable you to reach higher heights or power than a squat jump alone, which is a concentric only movement. So if we take the power from a counter movement jump, divide it by power from the squat jump, generally we would expect to see a ratio greater than 1.0, representing a higher capacity in the counter movement jump than in the squat jump. Research has confirmed that sports that rely heavily on explosive movements, such as football, soccer, rugby, Australian rules, tend to see higher EUR values in those sports compared to others. Here, for instance, we have data from Mike McGuigan's paper for some of these common explosive team sports. EURs for both jump height and peak power consistently greater than 1.0. It also may help us to track changes in adaptation and responsive to a training program. So again, in that same paper, we have this figure demonstrating changes in some of these sports in the eccentric utilization ratio in the preseason period compared to the off-season period. Much like our discussion on the dynamic strength index, which is this ratio between mid-thigh pull performance and counter movement jump performance, we can also use the eccentric utilization ratio to guide our programming decisions. Namely, if an athlete has an EUR greater of 1.1, then that suggests that they are able to make good use of their stretch shortening cycle and therefore achieve higher performance in the counter movement jump than in the squat jump. In those instances, athletes may want to focus more on strength training that helps to build that bigger engine that then translates hopefully to greater power capacities. If their counter movement jump performance is lower than their squat jump performance, so they have an EUR of less than 1.0, perhaps some greater emphasis on plyometric training would be beneficial. Now, of course, those are broad sweeping statements, and any training programs need to be designed with the sport in mind, as well as that individual athlete's injury history, capacity, and training goals. But let's take a look at a couple of theoretical examples to illustrate how we might use this. Here we have athlete A, and you can see the peak power shown in watts for the counter movement jump and their squat jump, giving us an eccentric utilization ratio of 1.17. They are achieving more than 10% greater output in their counter movement jump than their squat jump. That suggests efficient use of their stretch shortening cycle, and that we may want to focus more on strength training in their training program. Compare that to this second athlete then, who has fairly similar output across both jumps and then eccentric utilization ratio around 1. We'd probably want to include concurrent training in their program, hitting on both strength and plyometric capacities. Whereas an individual such as this athlete C, who is arguably underperforming in their counter movement jump performance, this low EUR of only 0.83, perhaps we want to focus more on plyometric training to train them to more effectively use that stretch shortening cycle. I also like this approach from the Science of Sport team, in which they have combined the EUR with other measures, such as force velocity profiling and the drop jump, to create this strength and power decision-making tree that helps to use these testing outcomes to determine the kind of goals that each athlete should have for their program and the kinds of exercises that might be used. One thing that is essential if you are going to use the EUR, or any data collection for jump tests anyway, is the data quality, particularly with a view to squat jumps. I've spoken about this before on a video on jump testing, but I want to reiterate the really strict protocol required to collect squat jump performance. It is very tempting for anyone when they are doing a jump to want to dip and to use that stretch shortening cycle to help propel them. So we have to be really tight on our athletes to make sure that they lower into that squat position, they hold it, and then they come straight up to ensure that it is truly a concentric only demand. Now with ForceDecks, we can use the force time curve to help us check and validate the quality of our data. So let's look at a couple of examples here then.
ForceDecks, the world's fastest, easiest, and most powerful dual force plate system. Assess physical performance in seconds. Jump, land, squat, push, pull, and more. ForceDecks automatically analyzes more than 20 common tests. You can even record video, which is automatically synced with your force data. Then find all your data and reports in one place, Vault Hub, including integrated norms based on millions of data points, helping give context to your athletes' results. And it's not just ForceDecks. You'll find all your Volt data in Vault Hub. One login, all of your performance data. Welcome to Volt.
So in this first case, we can see the green line showing the overall force, but also the blue and orange lines showing the unilateral forces, the left and right side that ForceDecks enables. We do not have this quiet standing period, which is necessary for the system to accurately capture the athlete's body weight and when they start the jump. It's perhaps harder to see in this example because of how wobbly this line is, but we do see a bit of a counter movement here immediately before the jump where force is lowered. Here we have a second example where we do have quiet standing phase immediately prior to the jump, but we see this dip, this unweighting where force reduces, that shows us that there has been a little bit of a counter movement used there, and therefore it should not be qualified as a squat jump. Finally, we have an example of a trial that I would approve as a squat jump, in terms of we have a quiet standing phase and then the force time curve increases immediately with the start of that propulsion up in the concentric only phase of the jump. The eccentric utilization ratio seems to not have too much discussion and attention in recent times, but there are two papers that I want to talk about briefly here. Firstly, this exploratory study from 2024, which discussed the potential relationship between the eccentric utilization ratio and a poorer rate of force development in the squat jump. These authors found a significant negative correlation between the eccentric utilization ratio based on either peak force or peak power and the rate of force development in the squat jump. Their discussion suggests that a higher EUR might not necessarily be about positive performance in the counter movement jump and the stretch shortening cycle, but perhaps a diminished ability to rapidly develop force in the squat jump. Now, remember, rate of force development, which I have spoken about in another video, and I'll pop a link to as well, is this ability to quickly develop force. So they're saying that looking at EUR alone and assuming that a higher value is better may not be the case, because it actually might be indicative of poorer squat jump performance. This is an important point that we talked about many times anytime we are dealing with a ratio. We like them because it simplifies things. Often it draws together two different tests, like this EUR, like the dynamic strength index. But anytime we are looking at some form of ratio, we need to look at the underlying metrics to get the context of what it means and understand the magnitude, the size of those component parts. We would never want to look at EUR in isolation, but also understand how that links, like we did earlier, to their actual counter movement jump and squat jump outputs. In the discussion of this study, they do talk about some of the potential mechanisms that may explain their findings, including some individuals having a better ability to pre-activate and pre-tense their muscles. They also talk about muscle slack and tendon slack and how that may influence the outcomes. And they reference another paper from Bas van Horen, published in 2017, talking about the underlying mechanics of the counter movement and squat jump performance. The EUR has often been linked to elastic energy, given the association with the stretch shortening cycle. But in this paper, they warn against linking it solely to elastic energy. And in fact, they also warn about thinking about it only in terms of utilizing one's eccentric abilities, given the downward phase that is also included in the counter movement jump. Interestingly, in their practical applications, they argue for replacing the name of the eccentric utilization ratio with the counter movement utilization ratio. I think it's worth bearing that in mind if you do start using this ratio, that it's not solely about eccentric capacities or elastic capacities, but it's just a representation of how well an individual may utilize that counter movement and therefore stretch shortening cycle. I want to thank Wild Performance for sponsoring this video and all the videos in our athlete testing series. And if you found it valuable, please like and subscribe to the channel so you don't miss out on another Sports Science Insights video coming soon.